The numbers unraveled. Let's unravel this problem. We need to find the quadratic residues and non-residues of 41. So for us to find it, we can use a theorem where it states that every odd prime p has exactly p minus 1 over 2 quadratic residues and p minus 1 over 2 quadratic non-residues. So our p is 41. Then p minus 1 over 2 is equals to 41 minus 1 over 2, which will become 40 over 2, and if we divide it, the answer would be 20. Therefore, 41 has 20 quadratic residues and non-residues. However, how are we going to know the 20 quadratic residues and non-residues? So let me refresh your memory about the definition of quadratic residue, where it states that let m be a positive integer. An integer a is a quadratic residue of m if a and m is equals to 1 and the congruence x squared is congruent to a mod m is solvable. If the congruence x squared is congruent to a mod m has no solution, then a is a quadratic non-residue of m. Since we already know earlier that from the theorem that 41 has exactly 20 quadratic residues and non-residues, we will just need to find the first 20 residues of x squared is congruent to a mod 41, and that would be 1 squared is congruent to 1 mod 41, 2 squared is congruent to 4 mod 41, 3 squared is congruent to 9 mod 41, 4 squared is congruent to 16 mod 41, 5 squared is congruent to 25 mod 41, 6 squared is congruent to 36 mod 41, 7 squared is congruent to 49 and also congruent to 8 mod 41 because 49 divided by 41 is 1.1951 something, and note that 41 times 1 is 41 and 49 minus 41 is equals to 8. Next is 8 squared is congruent to 64 and also congruent to 23 mod 41 because 64 divided by 41 is 1.5601 something, and note that 41 times 1 is 41 and 64 minus 41 is 23. Then 9 squared is congruent to 81 and also congruent to 40 mod 41 because 81 divided by 41 is 1.9756 something, and 41 times 1 is 41 and 81 minus 41 is 40. Then 10 squared is congruent to 100 and also congruent to 18 mod 41 because 100 divided by 41 is equals to 2.4390 something, and 41 times 2 is 82. Then 100 minus 81 is 18. Then the same goes to the rest of it. Therefore, the quadratic residues of 41 are 1, 2, 4, 5, 8, 9, 10, 16, 18, 20, 21, 23, 25, 31, 32, 33, 36, 37, 39, and 40. Then, the quadratic non-residues of 41 are 3, 6, 7, 11, 12, 13, 14, 15, 17, 19, 22, 24, 26, 27, 28, 29, 30, 34, 35, and 38. And that's how we unravel the mysteries of numbers on Numbers Unraveled.